Good day, folks. This is the DBE question paper. It's September 2018. This is the two-ball question on the vertical projectile of motion. Let's cut the chase. Ball Y is thrown vertically upwards from the ground at the velocity of 20 meters per second. Here's the sketch here. This is ball Y is thrown vertically upwards with the initial velocity of 20 meters per second. Now it says at the same instant a second ball X is dropped from the balcony above the ground. Now when they say at the same instant, they mean simultaneously. So it happened at the same time. While they're throwing this ball up, this one is dropped. So this is very important. The initial velocity of ball X is 0 and the initial velocity for ball Y is equal to 20. So guys, we will choose up as positive in this case. You can choose down as positive, doesn't matter. Guys, sorry for the sound, it's the rain. It's raining outside, but I hope you will hear me clearly. Okay, now a 3.2, I'm going to leave the definition of projectile. 3.2, it says, guys, another thing that is important here, when this occurs simultaneously, ball X is dropped and ball Y is thrown vertically, the time that they take, it's going to be the same. Okay, let's look at the question. Calculate the time it takes for ball A to pass each other. So the time that they're going to take to pass each other, it's going to be the same. So let's say they pass each other at this point. Now let's say they pass each other at this point. This is ball X and this is ball Y. So passing at this point, they took the same time, guys, because this event occurs simultaneously. What do I mean? That the time that ball X took to reach this point, it's the same, and the time that ball Y took to reach this point, it's going to be the same, right? And another thing that you need to notice, the height above the ground for both ball X and ball Y is the same, right? And the total distance that they are covering both, or the displacement, the total distance that they are covering both is equal to 50. If you look at this, ball X traveled this distance and ball Y traveled this distance. When you add both distances, they're equal to what? 50, right? So we can simply say here, we can simply say from that, this is 3.2, we can simply say that the displacement, okay, let me show you this. The displacement of ball X, it's change in Y, but it's negative because it's going downwards, and the displacement for ball Y, for ball X is negative. The displacement for ball Y, it's going to be positive because it's going what? Upwards. So when you add the two, they're equivalent to 50. Okay, let me write it here. So the negative displacement for ball Y, okay, that's X. For ball X, it's negative, and plus the displacement for the displacement for ball Y, they are equivalent to 50, as I've mentioned here. It's this plus this, they're all equal to 50 because they traveling in that. So we will use this formula that says change in Y is equal to VI, change in T plus half a T square for both. But this displacement for ball X is negative, so we should put it in bracket. So we'll say negative bracket vi change in t plus half a t square, and then we are here we'll say plus vi change in t plus half a t squared. This is for ball y, equivalent to what? To 50. And this is the easiest way. Okay, let's substitute now. What is the initial velocity for ball X? Since it's dropped, it's going to be what? 0. So it's 0, and the time is the one that we're looking for. Remember, I said the time for ball X is equivalent with the time for ball Y when they pass each other at that point. So it's going to be, the acceleration is going to be negative because we chose up as positive, and at the time we do not have plus. And the initial velocity, now we're in ball Y, the initial velocity for ball Y, it's what? It's positive 20 because it's going upwards. Change in t plus half, and the acceleration is negative 9.8. It will always be negative, guys. It's not because the ball Y, it's going up, it's going to be positive. No, it will remain the same, negative 9.8. Change in t square equal to 50. And then that negative will multiply there, so this will be 0. So that will be 0. So we'll distribute the negative inside there. So it will be positive 4,9 change in t. Okay, let me put it this way so that I do not confuse you. Plus, and okay, this will be plus 20 change in t, and this will be negative 4,9 change in t square equal to 50. Let's keep the 50 there. So negative times negative there, it will be positive 4,9 change in t square plus 20 change in t minus 4,9 change in t equal to 50. As you can see there, you have the like terms. The like terms here, it's this and this, and they have opposite signs. It's these two are going to cancel. You're going to be left with 20 change in t equal to 50, and then we both divide by, okay, let me do it in the next step. Say 20 change in t equal to 50, we divide by 20 both sides. So your time will be it's going to be 5 over 2, which is 5 over 2, it's 2,5 seconds. So the time the both balls took to meet each other or to pass each other there, it's 2,5 seconds. That's both their time. Okay, let's look at the alternative way to do this. We're going to look at the relativity, so which is the relative motion of both balls. So ball X and ball Y, okay, let me put ball Y at this point. They are both approaching each other. So as they're approaching each other, the velocity, as they approach each other, their velocity increases. The relative velocity increases as they approach each other. That's the relativity. So we can do this, use the formula that says velocity is equal to change in x over change in time, but in this case it's going to be what? Velocity is equal to change in y because it's a vertical motion. Change in t. So here, this velocity, it's going to be the relative velocity. So we're going to say velocity of x plus the velocity of y. Remember I said the relative velocity increases as they approach each other. So you add both. So it's going to be Vx plus velocity of ball y equal to change in y over change in time. Remember, what are we looking for? We're looking for time there. So the velocity of ball x was dropped, so its velocity is going to be 0, and the velocity for y, it's going to be what? 20. And then the displacement that they're traveling, it's going to be 50, as I've mentioned. So this plus this displacement, as they approach each other, they cover 50. So we'll say that is equivalent to 50 over change in time. So it's going to be 20 equal to 50 over change in time. And then we cross multiply, we'll have 20 multiplied by change in t, and then we divide by 20 both sides. So change in t, it's going to be what? 2.5 seconds. So they took 2.5 seconds. Guys, there are so many ways to do that, but I think these are the easy ones compared to the other ones. The simultaneous equation here works, but I avoided it because I want the simpler things for you, or the simpler way for you. Okay, 3.3, it says calculate how high above the ground ball x will be at an instant the two balls just pass each other. We want this height for ball x, right? So ball x covered that distance, it covered this distance from there to the meeting point, but we want the height above the ground. So we'll have to calculate that distance. It covered from the starting point to where the ball x pass ball y, and then we minus. So we'll say 50 minus this will give us the height there. Let's do it. So for ball x, it's 3.3. Now for ball x, this is what we have. We have time. The time for ball x is equal to 2.5 seconds. And then what else do we have for ball x? For ball x, we have the initial velocity, which is 0, and the final velocity of ball x we do not know. And the displacement for ball x we do not know. That's what we need to find first, and then we get the height. The question, it says how high above the ground. We are looking for a height, so we have to find the height as well. This is the first thing that we have to find, and the second thing, it will be the height. So how are we going to find the height? So we will use the equation that says change in y, vi, change in t plus half a t squared. And then let's see in this equation how we're going to use it. We are looking for this. We have the initial velocity 0, we have time, we have acceleration, we have time. So that's a suitable equation there. So the initial velocity is 0 and the time is 2.5 and half, and the acceleration is negative 9.8 because we chose up is positive, and the time it's 2.5 squared. So when you punch that in the calculator, you get the answer that is let me quickly punch that in the calculator. The answer there, it will be negative 30,625 meters. So that is the distance that is traveled by X to the meeting point. With Y. But what we wanted the height above the ground. So we got to this distance here. It's negative 30,625 meters. But what do we want? We want the height. So what are we going to do with the height? The height will be above the ground, will be the entire distance, which is the 50. We'll say 50 minus 30,625. Right, it will give us the answer that says 19.375, which is going to be 19.38 meters above the ground, which is this height now. It's 19.38 above the ground. I hope that makes sense. Get the last part of the question, which is 3.4. 3.4, it says draw a position time graph for ball X from the moment it's dropped until it passes point B, ball Y. Indicate the following on the graph: the initial position and the ball position of ball X above the ground when it passes ball Y, and the time the balls pass each other. Okay guys, here's the graph. As usual, we need to label our X's. So the initial position that they want us to indicate, it's what? It's 50. That's the initial position for ball X. Remember, ball X was 50 meters above the ground when it started from the edge of the building, or the height. Now the time that they pass each other, it's what? It's 2.5 seconds. It's 2.5 seconds, the time where they pass each other. And then the distance that it covered, the ball X, remember, it's the one we just calculated. It was 19.38. all right, so from that 19.38, it covered the 19.38 from the height. Remember, ball X, they met there. So this distance where they pass each other with ball Y, it was 19.38. We just calculated in 3.3. So, but it was coming from the height of a building. It was already in the 50-meter height. It was there, the ball X from the height. So that's why I start my graph there, and then it covers this distance to the meeting point, or where they pass each other there. So the curve it's going to stop there, and then the time it took, it's 2.5 seconds. So this is what you're supposed to show on the graph. You show the position of ball X. You show the position of ball X above the ground when it passes point B. So this is the position. And then time it take for ball X to pass each other, and this is time. This is what you're supposed to show. Now the graph is supposed to be like that, but Let's do more and see how we're going to plot the graph for ball Y. Ball Y, it starts from the ground, from the ground to the meeting point where they pass each other. So it starts from the zero ground, from zero, and then it increases upwards. So your zero was going to be there and your curve was going to be like this, and it took the same time, which is 2.5 seconds. The curve for Y, this is the curve for X and this is the curve for Y. Remember, the curve for Y, it was not asked, they only asked for X, not for Y.